Before I get into this talk, I want uh, I want people to realize that their imagination is more important than knowledge. What you think you know, and then what you can imagine, are they're not even comparable. So keep that in mind. If you have a good imagination, it will serve you, and it will do you a whole hell of a lot of good in the future for all the scientific matters that you might be curious about. But if you only have knowledge, you only know so much, and then that's it. You close your mind off into a little box, and then nothing ever comes of it. So for sure, imagination is more important than knowledge. In that case, I'm going to go ahead and start this off. This isn't going to be correct. What this is going to be is ideas. Okay. Now, there are many reasons why I have the pulsars as being disc-type structures with holes in the center. Because, well, there are many reasons. And I put this here just to give people some ideas. Say the disc was compressed only a slight bit. It would eject material very slowly. If it was a lot larger, it would eject material a lot more slowly. But if you compress the disk to incredible amounts, if the disk gets crushed, what happens is the object, its angular momentum increases, given it doesn't lose any mass, so it spins more rapidly, and the magnetic field would strengthen considerably. It would still have that hole in the center, you don't see it there, but the jets would then increase in velocity considerably. So there's that idea. The next page, I went with some ideas here. I did disc/torus may wobble, so you have your axis of rotation, and it spins like a tire. So imagine it's just like a little tire spinning around, and the jet going this direction. And you have, if you flipped the coin, if the axis of rotation was this way, and you flipped the coin with your thumb, how it would spin that way, and the jet would be like, it would spin around like that. But that's really weird. And then maybe you would have something like this where your axis of rotation is this direction and it wobbles, and the jet just sort of like goes like this on both sides like that. So there's that too. And here's a major set of reasoning, set of reasoning where I go over why I believe this disc orientation or torus orientation is a lot more efficient at moving matter. One good reason why pulsars are not spherical is because its shape does not allow for material to exit. With a spherical object that emits jets, how exactly would jets come from the surface of an object like that? That doesn't make any sense. You can put a big question mark there. And I wrote, surface acceleration only, 2D does not provide direction from motion. It's essentially flat. I mean, look at the Earth, okay? Now, given a pulsar is a lot smaller, still, it would be essentially flat. There's nothing to cause there to be any direction from motion. With a torus, or shall I say disc orientation, the whole body structure allows for acceleration of material. The material can accelerate through the body in either direction, this way or this way. And that's what happens, really. On to my next little drawing here. Also went over, I remember I used to look up things online about the pinch effect and how you can take magnetic fields and compress matter, you can compress metal cans with it. So say you have a piece of metal here, and you have current running through the coil or whatever, and then the magnetic field of the coil just compresses the can. I'm not too sure of its exact configuration, but you get the point. It pinches the material in the center. And with a spherical object, you can't really do that much pinching in the center because no material can be accelerated through the body. All the action has to be on the surface, right around here, on the surface of the three-dimensional structure. And that's really bad because nothing can move to the center. You can't get anything to be pinched because there's nothing there to get to the center. But with this configuration, you can have the body pinching as much material as you want, and it can move through the center. You can accelerate material through the center of this object. It says here, material can be accelerated through the body where the magnetic field is the strongest. I'm not too sure exactly what that would actually do, but there's my reasoning. This would block any material from moving through the body. This does not. And here is the last, the big point that I have been struggling with for about 4.5 years. This has been a giant struggle for me. People have no idea how mind-racking this has been. But where I was going with it, for some reason I wanted to go this direction. It starts off as a white dwarf, after planetary nebula. On both the Pulsar evolutionary timeline and the star evolutionary timeline, because both of these objects are very hot, very dense, and they were very new, very young objects, so they fit that criteria. And they both spin relatively slowly. Now, the pulsar's rate, okay, let me do the star first. The pulsar, the star, the white dwarf, I think its expansion is caused by too much iron and other materials entering the star. So you have a mostly helium / hydrogen type body, and then iron and magnesium and interstellar material rocks enter in. And it's like, damn, we can't do anything with that, so we have to expand to release all the heat. So it expands, and it starts spinning more slowly. Eventually it expands to the blue giant stage, and that obviously was covered in another video. And then it starts contracting again, going down the line that stellar metamorphosis covers. But with a pulsar, you have the star spinning slowly, and what happens is not a lot of iron and nickel enter in, so it starts spinning more and more rapidly and collapsing on itself. I do not understand the mechanism, but when it spins more rapidly, it starts to get more and more dense, and it begins flattening as it starts to spin more rapidly. And eventually, it'll become like a disc structure, and then it will spin so rapidly that the outside material will form a torus, and it will start ejecting matter and form a hole. So it's not a black hole, it's a literal hole inside of the object because it started spinning really rapidly, and it will start ejecting matter. And this object, since it starts ejecting matter, given whichever side will eject matter, say it ejects matter this direction, that means the object will move in this direction, equal and opposite reaction. But if the matter ejects in this direction, it'll start moving in this direction as well. The matter is ejected in both directions as the object evolves. But this is what provides the initial kick for getting the object out of the galaxy. So it pushes itself out of the galaxy, ejects itself through either the arms of the galaxy or straight up the middle or down the side of the galaxy. And then it reaches the point to when Baz had drew it earlier, where you have giant lobes forming and start spinning and twirling like this. And then the object will begin, going this direction, and it will start forming the giant barred spiral arms or the spiral arms of the galaxy. And that material that's coming out of it at near luminal velocities is what's providing the fusion, the velocity required for fusion reactions to overcome the Coulomb barrier. And the material will be forming, billions and billions of stars, which will then, once the galaxy evolves considerably and you have a big, spirals, all the stars will form along these little arms right here as it dissipates the energy. And that's why the arms are much brighter, because they're full of younger, hotter stars. And then, they start interacting and mingling with each other and forming, solar systems on very vast scales. But that's basically it. Man, I spent about an hour of my time going over this in my class. I mean, I was paying attention to the class too, but I was drawing this at the same time. Alright, today is March 21st, 2016. Later, y'all.